Now, earlier, we talked about something called an additive inverse, that when we add it, we get 0, and something called a multiplicative inverse, that when we multiply by it, we get 1. And we also named something called an inverse function. I wonder if those names have anything to do with each other. Yeah, in fact, those names are carrying the same meaning. They are, in a sense, something that reverses something with respect to a specific operation. And the inverse function is the inverse with respect to composition. Namely, if I compose a function with its inverse, I get the function that does nothing, the function whose output is the same as its input. So when I compose a function with its inverse, I'll get just my input variable back, whatever my input variable is. And that's neat because we can use this when we want to determine whether or not two functions that we meet in the wild are inverses of each other. And two, we're going to be able to use this to undo the effects of functions later on in the course. So let's just confirm this property for a moment. Here we're given two functions, and we're asked to compose them and confirm that in fact they're inverses of each other. So we'll take f composed with g of x. That'll be f of g of x. So that'll be f of g is the function that takes 5/2 x plus 10. F takes 2/5 of its input and subtracts 4. And in this case, the input is 5/2 x plus 10. Now we distribute. 2/5 times 5/2 is just 1. We're left with just x. 2/5 times 10, that's 4. And then x plus 4 minus 4, we just get x back. F composed with g of x just gives us x back. In the other direction, g composed with f of x, that's g of f of x. So that's going to be g of 2/5 x minus 4. Now g is the function that takes 5/2 of its input and adds 10. And here its input is 2/5 x minus 4. Simplifying, we'll distribute the 5/2. 5/2 times 2/5 is just x. 5/2 times -4 is -10. And we'll add 10. X minus 10 plus 10, that's just x. So g composed with f of x also gives us x back. In either direction, when I compose f and g, I get the function that just gives us our input back. Therefore, f is the inverse of g, and also g is the inverse of f. And assuming the domains and ranges line up with each other, so assuming the domain of f is the same as the range of g, and the range of f is the same as the domain of g, when we're checking for inverses, it's enough to compose in one direction. If it works out in one direction and the domains and ranges line up, it's going to work in the other direction as well.